Hey everybody, this is Mr. Beckstrom, and today we're going to look at some examples from section 3C, and they do ask quite a bit about finding the precision and the accuracy or the number of significant digits in values. So let's take a look at some examples here, and I'm going to go ahead and use this chart up here, and you can use this as well. And this is how we find the number of significant digits in values. It looks pretty complicated at first, but once you use it quite a bit, we're really just counting the number of values that are needed in order to basically measure something. Let's first talk about it. Non-zero digits. So any numbers here that are not zero, so all of these numbers here, those are always counted when we're counting the number of significant digits. So we always count those. Zeros follow a non-zero digit and lie to the right of a decimal point. So anything to the right of a decimal point, any zeros that are to the right of a decimal point, we always count those as well. So those are always significant. So when we're adding up our significant digits, we always count the zeros to the right of a decimal place. Zeros between non-zero digits or significant zeros. So if we've already established that a zero is significant because, for example, it's at the right of a decimal place, any zeros between significant digits, those are also significant. So those are also always counted as well. So these are all of the values that we always count. Now, what is not counted in a number? What don't we count as being significant? What are the things that we leave out of the number of significant digits? Well, those would be, the big one is the zeros to the left of a value. So if we have like this number here, 0.00052, all those zeros on the left, we never count the leading zeros. So all the zeros before the first non-zero number, we don't count those. So for example, this number here, there would only be two significant digits because we never count the leading zeros. So any zeros before the first non-zero number, we don't ever count those. And then the other thing we don't count is we don't count any zeros on the right, the following zeros or the last zeros on a whole number. So we're not talking about decimal numbers. So if it has a decimal place, ignore this. But if it's a whole number, and it's like, for example, if they said 40,000, then we wouldn't count any of the trailing zeros. Those are at the end. Or this number here. So in this case, we'd only have one significant digit because we don't count any of these. Or here, we'd only have two significant digits because we wouldn't count this last one. But this only counts with whole numbers. So now, that's when I teach this. That's usually the biggest question I get asked. How come we don't count these zeros? Or wouldn't these zeros be significant? And so I guess the biggest kind of example that I like to use in when I tell people why these aren't significant is, as I say, well, how many people are in the United States? And since I'm doing a video, I'll have to answer that question for myself. Oh, there's about 330 million people in the United States. Okay, great. And then I follow that question up. Okay, two people were just born down the street or at the hospital. Now, how many people are there? Well, there's still about 330 million, but wouldn't there be 330 million and two because there were just two people born? And then you think for yourself and you're like, no, that doesn't make any sense because, well, why? Well, because when we said 330 million, we were only counting to the nearest, what, 10 millionths place, right? So when we said 330 million, right? 0, 0, 0, 0, 0, 0. When we told you that this was the number of Americans in the United States, we only really we're precise up to this digit right here, right? All of these zeros here, we weren't really using these in our measurement here. We were only precise up to the 10 millionths place. So that's why only these two digits here were actually accurate. So this number only has two significant digits. None of these were used in our counting. So that means when I say two more people were born, why don't we have 330,000,002 now? That's because we weren't using any of these digits in our estimation. So none of these were significant. So that's what it means when when these trailing zeros of a whole number aren't significant. All right. So once again, pretty much everything is significant except for zeros at the end of a whole number. Now, if I have something like this, let me just give you another example. Let's say I have 300, let's say I have 330 million 0, 0, 1, 0, 0, 0. Then the number of significant digits here is going to be 6. Why? Because this 1 is significant and all the zeros between non-zero digits or between significant digits are significant. So now I counted all the way to this one, so these zeros become significant and these trailing zeros are no longer significant. So now all of those are significant. So now we have 6 significant digits here. So this would be 6. We don't count those. All right, so it does get a little bit tricky, but once we think about it realistically about which of these values we're actually using in their measurements, why are those staying there? I gotta change that right there, but it's still not getting rid of it. Let me see if I can white pen this away. Maybe not. All right. Well, I guess we'll just have to deal with that for a little bit. All right. So now let's talk about these numbers here. We're going to do the number of significant digits, and then we're also going to talk about the precision. And the precision is the place of the rightmost significant digit. So the precision is the place of the rightmost significant digit. And we'll talk about that when we're going through here. All right, so the first number here is 1,342. I think we can all agree using this criteria that we have 1, 2, 3, 4 significant digits. Pretty easy. So this has an accuracy of 4, or a number of significant digits of 4. And the precision is, it's precise to the ones place. So if the decimal place, if we did put 1 in here, it would go right here. This would be the ones place. This would be the tens place. This would be the hundreds place. This would be the thousands place. This would be the tenths going this way, the hundredths, the thousands, the 10,000s, and keep going on that way. So the rightmost significant digit is the ones place. So this is the ones place. So this is precise to the ones place, and we have 4 significant digits. All right, let's take a look at this number. This is 1.4 times 10 to the 4th. Well, already I can see that I have 2 significant digits. But in order to see how precise it is, I'm going to have to take this out of scientific notation. So out of scientific notation, I'm going to have 1. I'm going to have to move that decimal place 4 to the right. So it's going to give me some zeros here. It's going to give me 3 zeros, right? So 14,000. So 1, 2, 3, 4. So 1, 2, 3, 4. And I will see that even though these zeros are not significant, I still add them here when I take it out of the scientific notation. And this is precise to the thousands place. The rightmost significant digit is the thousands place here. All right. This is the ones, tens, hundreds, thousands place, and the 4 is my rightmost significant digit. All right, here Now notice I have a decimal point. Notice I have a decimal point, right? So that means this 0 is significant, right? There's no reason I would put that 0 there with a decimal point unless I actually measured that far. That's why I put the 0 there. If I didn't measure that far, there's no reason I would put that 0 there. So the reason I put the 0 there is because that means that I actually went that far out in my measurement. So that means that this has 4 significant digits. Remember, zeros are significant. They are significant when to the right of a decimal place, when I go to the right. So 4 significant digits, and in order to see what my precision is, I'm going to take this out of my form. So this is 10 to the negative 3, so I have to move the decimal place 3 to the left. So this is going to be 0 point, and I'm going to have 2 zeros before that first 3. So 3, 3, 3, 0. So let's see, that would be 1, 2, 3. That would be right. And now my rightmost significant digit is this one right here. And let's see what place that is in. So here's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So let me spell that out. Millionths. You want to put that little something like a TH at the end to distinguish it from millions. Millions would be on the left, millionths would be on the right. All right. And lastly, and I don't know if it states it in here, but if we put an over bar over a 0, that's a way for us to signify that we actually measured that 0 in a whole number, because there's really no other way for us to say, no, we actually measured this far in a whole number. We actually got a 0 there. So if I put an over bar over a 0 and a whole number, it says, no, we actually went that far in our measurement, and it was actually a 0 there. All right. So this one has 1, 2, 3, 4 significant digits, because this 0 is significant and all zeros between significant numbers are significant. So 4 significant digits, and this is precise out to this is my rightmost significant digit, and this is in the ones, tens place. So it is precise out to the tens place. All right, I hope this helped. If you have any questions, please let me know, and I hope you have a great rest of your week. Thank you.